Okay, today I am going to be going over the Circuit Worksheet. Uh, I have now, unfortunately, the this worksheet is like it doesn't like being edited for some reason. I don't know why. I I think the original it's because I got this as a PDF and then I switched it to a dot a doc. So I think that's probably the reason why it's kind of messed up. But I I don't know. So I sort of I've done kind of a couple things. I have, of course, there's this, but I've written the numbers out, sort of like this on this Word document, and then what I've also done is I've actually, well, that's the final one, but I have created some of the circuits in the lab, and so we can kind of compare and go through the numbers and stuff like that. But for now, we're going to start simple enough with this first one here. Um, so, uh, in terms of solving this, there's really only a couple things you need to know. You need to know v equals IR. Now, the n here, that's just telling you that, like, it doesn't matter. You can use any of the subscripts. The only key is that it has to be the same subscript, okay? So it could be v1 equals I1 times R1, or it can be v3 equals I3 times R3, or v total equals I total times R total. It doesn't matter, okay? So that's also why I've kind of laid these out the way I have. So v equals IR works for, well, it doesn't work like that, but it works for these three, works for these three, and these three. But you can't combine. You can't say v2 equals I3 times R total, right? You can't do that. So that's sort of what the n is saying. And then just saying, well, if you have a couple resistors in series, you just add them together to get that equivalent resistance. And if you have a couple of them in parallel, you just do the one over and you do that. So with those three things that are honestly fairly simple, you can figure all this stuff out. And again, the hard part is just the logic behind it and the paths and figuring out what to do. But, it's not so bad. So let's start simple enough. The first one here, they're all in series, and they all have a resistance of 3. So what's the total resistance? Well, they're all in series, so you would just add them up. So the total resistance is going to be 9. Now, if the total resistance is 9 and the total voltage is 9, therefore, V equals IR, we can divide this through. So, here, I'll even write this out. So, R total equals oops. I'll be perfectly efficient. Not efficient, but I'll explain everything basically. So then, since we have V total equals I total times R total, we therefore have that 9 equals I total times 9. So I total equals 1 amp. Oh, there is one more thing that we need to know, actually. There are a couple, two things. And I forgot about this. Let me put this in here. So the first is that in series, V total equals V1 plus V2 plus V3. And that I total equals I1 plus... equals I1 equals I2 equals I3. Like that. Okay, so that's if they're in series. In parallel, that's... Okay, there you go. So V total equals V1 equals V2 equals V3. And then I total is the sum. Okay, so that's covers all that we need to know now. So we have now, based on what we have, okay, so what do we have? Again, this is all in series. So let me write that in. All in series. Okay, so they're all in series. So, right, because, yeah, they're all in series. So since they're all in series, we have I total. I total equals each of the individual currents. So therefore, I3 is 1. I2 is 1. And I1 is 1. So, put that in here. Those are all equal to that. So now we have I1 and R1, I2 and R2, and I3 and R3, so we can use V equals IR to solve for V1, V2, and V3. So V1 equals I1 times R1 equals 1 times 3 equals 3 volts. And hopefully you can see that all of the other resistors are the exact same. It's just now it's all 2 because the numbers are the same. And now they're all 3, but the numbers are the same. And we can check, because again, in series, the voltages should add up. So do they add up? 3 plus 3 plus 3. Yes, that gives us 9. So this is what we should have. So if we actually put in the numbers here, we have 1A, 1A, 1A. Oops. We have 3V, 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 and this is 1A, and this is 9 ohms. Okay, so that covers everything for that. All right, and we can check this. It's the circuit that's over here. So let me make sure I got this right? So it's I might have the order switched around here. I don't remember. Okay, yeah, so that's -3. Okay, so it doesn't really matter, but so this should be that side, and this should be that side then. So there. That's 3, so that's around the first one. Also 3 around the second one. And also 3 around the third one. And then we can take out the amp one also, and we can see 1 amp, 1 amp. It's all 1 amp. So yeah, okay, good. Second one. Now they're all in parallel. Now they all have the same resistance. Battery's different, but they're all in parallel. So all in parallel. So if they're all in parallel, that means 1 over R total is 1 over R1 plus 1 over R2 plus 1 over R3. So we have 1 over 12 plus 1 over 12 plus 1 over 12, which is, well, 3/12. Therefore, our total, because again, 1 over our total equals 3/12, so our total is 12/3, which is 4. That's our total resistance. It's going to be 4. And now, we have R total and V total, so we can solve for I total. So we have 6 equals I total times 4. So I total is going to equal 1.5 amps. Okay, so now these are all in parallel, and when they're in parallel, the V's are all equal. Okay, so V total is that, so therefore, where's the thing? There we go. So V total equals V1 equals V2 equals V3. So those all equal 6V. So these are all going to be V, 6V. And again, now we can use V equals IR. V1 equals I1 times R1. So we get 6 equals I1 times 12. So I1 equals 0.5 amps. And again, you should be able to see pretty clearly that this all lines up quite nicely. And unfortunately, I can't get this on one line, so let's do it again. Again, all the numbers are the same here. And again, you can see that now we have, since it's in parallel, the currents add. So .5 plus 0.5 plus 0.5 equals 1.5. So yeah, all that works out. So we have 0.5 amps, 0.5 amps, 0.5 amps, 6V, 6V, 6V. Total resistance ended up being 4 ohms, and the total current was, 1.5 amps. Okay, so now we got that out of the way, and again, we can double check here. So we have, come on. We got, yeah, well, -6, but, same thing stands. 6 and 6. Yep, that all works. And we can check over here. We got, let's see, total current, 1.5, then 0.5, 0.5, and 0.5. Yep, all seems to line up well. Okay, next up, series again, but now the resistors are different. So we can't just, copy and paste the same numbers over and over like we did before. So all in series still. So we have R total equals R1 plus R2 plus R3. So we have 4 plus 8 plus 6, which is 18. That's our total. We have, let's see, so then we have that, and then again we can use V total equals I total times R total. I'll move it down. So we get 9 equals I total times 18. So I total equals 0.5 amps. Okay, and again, they're all in series. So if they're all in series, then the voltages are equal. Wait, no, they're not. The voltages are adding. The currents are equal. Yeah, they're all in series. The currents are equal. So, therefore, that equals I1, which equals I2, which equals I3. Okay. So all the currents are going to be 0.5. Okay. And now we can solve for the voltages. So V1 equals I1 times R1. So we have current of 0.5 times voltage of 4. So we get 2 volts. V2 equals I2 times R2. So 0.5 times 8. It's going to be 4 volts. And V3 equals I3 times R3 equals 0.5 times 6, which equals 3 volts. Whoop, that's not a 3. There we go. And remember, also, if they're in series, the voltages should add. So, V1 plus V2 plus V3, 2 plus 4 is 6, plus 3 equals 9. Yes, lines up perfectly. So, all works out. So we have, going to the worksheet, we have, what was it? It was 0.5, right? Yeah. 0.5 amps, 0.5 amps, 0.5 amps. Then we have 3 volts, 4 volts, and 2 volts. Current total of 0.5, and the total resistance of, what was it? 18. Okay. Oh, and let's check with the lab. So we have, I think it might be negative here. Yeah, that's, okay, so that's 2. 4, This should be 3. Yep. And currents should be all 0.5, 0.5, all 0.5. Yep, okay. So that covers it with those ones then. Okay, next up, circuit number 4. Now, same kind of situation. It's parallel again, but now the numbers are different. So, all in parallel. So, 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so we have 1 over 6 plus 1 over 12 plus 1 over 3. That's not 1 over 3. 1 over 3. Okay. Now, you could just put this in a calculator, but I'm going to do it the hand way. So 1/6 equals 2/12, and 1/3 equals 4/12. So this equals 7/12. Yeah. So therefore, our total equals 12/7. And okay, this time I'll use a calculator. 12 divided by 7. 1.7143. Although, I should probably just keep it as a fraction. Because that usually makes the multiplying easier. So, you know what? I'm actually going to keep it as a fraction. I'll do both. So, or 1.714. Okay. So, therefore, we have that the... well, let me put this in. So, again, I'm going to write it as fractions, but you can transpose if you don't want to. Let me make 100% sure I did that right. So 1 over 6 plus 1 over 12 plus 1 over 3, and then invert it. Yeah, that's right. Okay. So now we have that. Again, we can solve for I total. So So 6 equals I total times 12/7. So it's the inverse of this, which is 3.5. Right, yeah, okay, yeah, that makes sense. So I equals 3.5. It would be that. But I'll keep that as the decimal, because that's a simple decimal. Okay, so now, let's see. This is all in parallel. So if they're all in parallel, that means the voltages are all the same. So this is going to be 6. Verify that. All right. And then we can solve for the currents. So V1 equals I1 times R1, which ends up being 6 equals I1 times 6. And everyone can agree that therefore I1 equals 1 amp. Okay, V2 equals I2 times R2. So we get, again, 6 equals I2 times 12. So I2 equals 0.5 amps. And V3 equals I3 times R3. So we have 6 equals I3 times 3. So I3 equals 2 amps. And again, since they're in parallel, the current should add up. So 1 amp plus 0.5 amps plus 2 amps, that does equals 3.5. So we get 1 amp. This is the 0.5 amps. 2 amps. Okay, so this ends up being 1 amp, 3.5 amps, 2 amps, 6 volts, 6 volts, and 6 volts. This is 3.5 amps, and this is 12/7 ohms. All right, now we get to the more complex ones. So circuit 5. Let's see what we got here. So R2 and R3 are in parallel with each other. So 3, and then together are in series with R1. Okay, so this will help us figure out the total. So these two are in parallel with each other. Therefore, we can solve for that parallel piece. So 1 over R, I'll say 2, 3. Basically, the total, the total for just 2 and 3 put together is going to be then in parallel of these here. So we get 1 over 2, which is 4, plus 1 over. I want to get rid of that. What the heck did I do? 1 over 4. Oh, I hit the numlock thing. Okay. I'm hitting too many buttons. Okay. No! Oh my god. Okay, 1 over 4 plus 1 over 4. That was a lot of work. Equals, this would be, well, 2 over 4. So therefore, R23 equals 4 over 2, which equals 2. And then our total is now, again, that's in, because then now you're putting it in series with R1, so it's going to be R1 plus R23. So we get 4 plus 2, 6 ohms. That is our total resistance. And therefore, again, current, now we have that. We can use V equals IR. So we have 12 equals I times 6. So I it okay, here I'll nope, this doesn't work. I'll IT. You get the point. Okay. It still works. Okay, so we have 2 amps. Okay, now the tricky part is figuring out, okay, how do we get the currents and voltages? Well, remember the totals, the total current and the total voltage, you can also think of these as the current and voltage for the battery. Okay, so the current and voltage for the battery. So the battery is in series with R1. Okay, this means that it follows the relationship between the voltage and current between R1 and the battery is the same as for the general series rules. The general series rules is this here. So the voltage is equal and the voltage is additive and the current is equal. That means I1 must equal I total because it's in series. Those two, the first resistor is in series with the battery. So that's going to be 2 amps. So let's put that in there. I1 is 2. Okay. Now what this means is that now we can solve for V1. So we have 2 times 4. So it's 8 volts. Okay, so I1 is 8 volts. Now, again, now voltage is additive. Now, what are in series? But what are our series pieces for voltage? We have V1, and then we have 2, 3. Right? This 2, 3 piece together is in series with the 1, which is then in series with the battery. So this means that V total equals V1 plus V23. Now, what is V23? Well, you can, do that down, actually. Well, we have V total is 12. V1 we just solve for 8. So therefore, V23 equals 4 volts. In other words, these two together have a voltage of 4. Now, that piece, though, is in parallel. So that piece follows the parallel rules. And the parallel rules state that the voltages are equal. So in a sense here, for this parallel rule, V23 is this V total for that parallel piece. So, therefore, V23 is 4, but that also means V2 and V3 are also 4. And think about it. So if you are gaining 12 volts going across the battery, you then lose 8, well then you must lose the other 4, but you can either go through 2 or go through 3, but you have to go through one of them. You're also not going to like do a weird loop and go through both. So you must lose 8 here. You therefore must lose 4 regardless of which one you go across. So this leads to this one being 4 volts. And this one being 4 volts. And now we can solve for I1 and I2. Or no, I2 and I3. So we have V2 is 4. I2 times R2, which is 4. So therefore, I2 equals 1 amp. And we can just copy this entire line over again because the same numbers. It's now for V3, I3. That, okay, because it's all the same. And again, think about this in terms of the current rules. The current rule for the parallel piece is that they should add. So I2 plus I3 should equal the sum. And, well, go back to the circuit. Think of it this way. The current that goes through R1 then splits going into R2 and R3. Okay, it splits going into R2 and R3. Therefore, whatever the current is for 1, it should equal the sum of 2 and 3. And does it? I1 is... Where is I1? I1 is here, 2, and then I2 is 1, and I3 is 1, so yeah, it does line up. So it lines up there. And, oh, I just realized I forgot to show this. I'll show this in a second. So this current should be 2, this should be 1, this should be 1, this should be 8, this should be 4, 4, and so the total current is 2A, and the total resistance is 6. Okay, so let's also go back here and show what this is on the... I have a second tab here. Okay, so let's take this out. And we want this one to go here, I think? Negative. Okay, so wait, is that what I had? Okay, I had them all be 6, but again, negative doesn't matter. 6. And 6. So that all works that way. And then the here, so you get 2.5 and 1. Yeah, that's what the answers were. Okay, so then this was the one over here. Wait. Oh, I forgot to change this one. Whoops. Okay. So, what were our voltage numbers? We had 8, 4, and 4. Okay, so this one should be 8. Yep. This one should be 4. Well, negative 4, but here, well, I'll make it accurate here. Okay, 4. And 4. And then the currents should be, what is it? Was it 2, 1, and 1? Yeah, so 2, 1, 1, total currents 2. Okay, so far so good. Next one up. Very similar situation here. Slightly different though. First of all, the numbers are not the same, but we have, let's see, R1 and R2 are parallel. So R1 is parallel with R2, and then both are in series with R3. So, see, so again, in parallel, so we have R1 and R2 together are parallel. Okay, so we have 1 over 6 plus 1 over 3 equals, well, I can kind of make this easy because 1/3 is just 2/6. So this ends up being 3/6, which hopefully you can figure that out. That if 1 over R12 is 3/6, that means R12 equals 6/3, which equals 2. So then the total here is then, because those are now in series with R3, that our total equals R12 plus R3, 6 plus 7 is 13. I did put that one right on this one, right? 60, yeah, okay. Just making sure I had the numbers right there. So then we can get the current. We have 9 equals, I'll say T just to save space, times 13. So IT equals, put this down there, just space. So, okay, here, I'll space it out, I'm being specific here. 9/13 amps, or what is 9/13? I don't know. That 0.6923. Okay. I'll keep it as a fraction, just because again I think that's generally the better way to look at it. Okay. Yeah, okay. So again, same logic as before. Remember, this is the same thing as the battery. So what is the battery in series with? The battery in this one, let me actually think. Okay, the battery is now in series with R3. Okay, whoops, I'm losing my tabs here. Okay, so therefore, series rules is that this must equal, the current must be equal to the total, therefore, so that must equal I3. So I3 is 9/13 amps. Which then means we could solve for V3. I have a feeling these numbers are not going to look very pretty, but we have 9/13 times 7, which is 56/13, I think. 63/13. 8.486, or no, 4.846, sorry. Okay. And this is 3. Okay. Yeah. So again, I know it depends on the numbers you have. I know you might think like, why are you doing the fractions? Usually the fractions kind of make things easier. It seems like here they're not really, but I'm doing my best. Okay. That's fortunately very close. You know what? Just there. And I know I should have it split like that, but I want to make sure that that's distinct. Okay. So now same kind of situation where we had the voltages kind of add up, right? We had V total is V1 plus V23 over here. Well, here it's similar, but it's a little bit different. So it's that V total equals V12 plus V3. So we have 9 equals V12 plus 63/13. Right? Yeah. So what does that give you for V12? Well, the positive version of this, which is 54/13. .154. And again, since now this is the parallel piece, it's the voltage of this total in parallel. The voltages are equal. Yeah. So, and then now we can solve for the currents. So, V1 I1 times R1 equals, let's see, wait, no, not equals, V1 is 54/13 equals I1 times 6. So, let me move this all down a row just so it's all together. So I1 equals 54 divided by 13. Whoops, nope. Divided by 6, it should be 9/13. Wait, that's not right. Wait, that's not right. I messed up somewhere. Where did I mess up? Hold on. Did I make this unnecessarily complicated by using it all as... Hold on, did I do something wrong in the beginning? No, that equals 2. Oh my god, I did this all wrong. Okay. Oh boy, this should be 2, which makes this 9. How did I was seeing the 6's and that confused me. Okay, that's 9. So therefore, 9 equals times... Wow, I made this way harder than it needed to be. Okay. I total equals 1. Yep, okay. Okay. You can see how one mistake completely messes everything up. Boy. Okay, so that's I3. Therefore, I31 equals, okay. 9. Wait, I3. Hold on. Okay. 3 equals 1. I have to slowly rebuild all this. Hold on. Okay, so that's equals I3 equals, okay, no. 1 times 7 equals 7 volts. Okay, right? Making sure. So this should be 7. Okay, therefore now we have this here. Yeah, so 9 equals that plus 7. You can see how, you did see though, I did catch a mistake, because I was like, wait a minute, this doesn't seem to work, because this, I was getting a number that was, so that this current would have equaled this number, which doesn't make any sense, because it's not in series at this point. So, I did make a mistake that caused me to kind of redo all of this, but it's, I was able to actually catch it. I was able to realize, hey, wait a minute, this is wrong. Because you could get, wait, how do you know it's not a gross fraction, right? So, and let me back. Okay. Because they're in parallel. Yeah, so then these are all 2. And this is 2. Oops. Okay. Now we can solve for this, and it's a lot easier. So we have 2. Current is 3. No, not 3. 1/3. Yeah. And V2 equals I2 times R2. So we have 2 equals I2 times 3. So I2 equals 2/3, or 0.67 amps. Okay, I think I did all that right now. Oh boy. Double check. Okay. So we have, let me put the numbers in first. Okay, so we have the currents for all, let's see, 0.3, 0.671. Voltages are 2, 2, and 7. Total current is 1 amp. The total resistance is 9. Okay, so let's make sure that that's all true. Let's see, total voltage is that. Okay, so we have 7. I always forget the order here. This one is should be 2. Yep, and this one also 2. Okay, so that's all good. Total current, we had 1, 1.33, 0.67. Okay, I did it right. The second time I did it right. Okay. Yeah. Oh, you can see how this is going to be tricky and how, again, just one small mistake in the beginning screws everything up completely. Okay, now this one, I couldn't really create these in the lab because, the resistances are missing, and also, even if I could sort of like, because one thing you can do, for example, is you can hide the values, so then you you don't know what the resistances are, and then you could check though, but what is the current? Oh, that one's 0.3, and I could kind of build it up that way. The problem is that in the values for the resistors, I can only do it by increments of 1/2 of an ohm, and I know some of them are like weird fractions, or weirder fractions, so it doesn't work. I can't build anything that's really accurate here, so I can't really build something to show this off. But we got to kind of use logic to figure this out. So this is where things get a bit interesting. All right, so 7. Now these are all in series, so all the series rules apply. Okay, now first thing to notice is what you should always do for these is notice, okay, is there any of these kind of pairings here where there's 2 of the numbers? And there's 2 of these numbers. Okay, so therefore, V total equals I total times R total. Immediately kind of figure this out because we need V total. So we have I total is 2 times R total is 9, therefore V total is 18. Okay, we can immediately figure that out just from knowing those 2 numbers. And I'll not put it in yet. Okay, so now they're all in series. So what are the series rules? The series rule is that the currents are equal. They're all equal to the total. So I1 equals I2 equals I3, which equals I total, which equals 2. So all of these are 2. Let me go in order. Okay, and now we can see we have 2 of each piece, so we can use V equals IR to solve for everything else. So let's do 1 first. So V1 equals I1 times R1. Now we're actually solving for resistance this time, but it's 2 equals 2 times R1, so R1 is 1 ohm. I think that's pretty easy to tell from that. Now you could sort of take a shortcut here and say, well, I know the total is 9, and my these are all in series, so they should just add, right? So like so. So we have 9 equals 1 plus R2 plus 3. R2 equals 5. And you can check that because, well, V equals IR. So V10 equals I2 times R, 5. Yeah, that lines up. And then voltages, you can solve this one either way you want. I'll just do this way. So we have 2 times 3, so we get 6 volts. And you can also check, again, since they're in series, the voltages should add. So 2 plus 10 is 12, plus 6 equals 18. So yeah, lines up in that sense. So yeah, these numbers work. I guess I could have made this resistor, I guess, but there's this circuit in the thing and just hid the values. But the other ones are not necessarily the case. So let's see. Okay, what do we have for the numbers here? So we have 3, we have 1, 5. Okay, currents are all 2. This is 6V, and the total is 18V. Okay, moving on to the parallel one. This was kind of off, so let me... There, it's all in one thing. Okay, so now, all in parallel. And again, notice we don't have any of these, but we have 2 of these. So V total is I total times R total. So we have 4 times 1, so voltage is 4. Now they're all in parallel. And again, what's the rule here? The parallel rule is that all the voltages are equal. Okay. And now we can solve for, well, a couple other things. So, let's do I1. So V1 equals I1 times R1. Let's see, V1 we have 4 equals I1 times 8. So I1 is equal to 0.5 amps. Let's see. V2 4 equals 2 times R2. So R2 equals 2 ohms. Let's put these in. And 2 ohms. Okay, now we still have two unknowns here. So there's a couple ways you could do this. One is if you want to, you could sort of work backwards through like the parallel resistance kind of thing. That's generally harder to do. We probably don't want to do that. The easier way to do this is to think, okay, again, look at the other rules. Well, what's the rule for current? The rule for current in parallel is that they should add up to the total. So we have 0.5. Let me write this out. So we have I total equals I1 plus I2 plus I3. So we have 4 equals 0.5 plus 2 plus I3. So I3 equals 1.5. And then we can work backwards to get to R using Ohm's law. So we have 4 equals 1.5 times R3. And R3 equals... I'm being paranoid right now. Okay. Yeah, see, this one I couldn't exactly make work. And you can check this, again, because the parallel, this thing should work. So 1 over 8 plus 1 over 2 plus 1 over this should equal, well, 1 over 1, which is 1. So let's check that. So 1 over that plus 1 over 8 plus 1 over 2, yes, it equals 1. So this does line up, works out. There we go. All right, this one is where things really start to get tricky, because not only do we not know a bunch of values, but we have a more complicated scenario. So what do we have? R2 is parallel, that's wrong, with R3, and both are in series with R1. Okay, now you'll notice right off the bat that none of these 4 things have 2 numbers, so we can't just immediately use V over equals IR. So instead, we have to use the rules of series and parallel. So, in parallel, what do we have? We have R2 and R3 are in parallel. Now again, parallel rule is that the voltages are equal. So, therefore, V3 equals 8 volts. But that must, because they're in parallel, that's in parallel with R2, that must also be V2. We can therefore use equals IR to solve for I2. Because we have 8 equals I2 times 4. So I2 equals 2. Okay, we have that at least. What else? Okay, so what else can we do? We have those voltages. Okay. Oh, well, we have the voltages. Okay, so again, these voltages are equal. So this also means this part here is also saying V3. Since V3 equals V2, and they're in parallel, that also means, again, the voltages in parallel are equal to also the total of the parallel. So that equals V23. Now, that is then in series with V1. So what this and in series, it's additive. So we have 4 plus 8 equals 12. So V total is 12. We can then use equals IR. We have 12 equals 3 times 4. Well, it does equal... Okay, it's our total, but our total equals 4. That's not a total. Okay, 4. Okay, so we have that at least. We have these numbers going so far. Okay, now what else do we have that we can use? We have... Oh, okay, remember these are numbers for the battery. Here. So this battery is in series with our 1. So, and in series, the currents are equal. We can now solve for we can solve for R1. So V1 is 4 equals 3 times R1. So R1 equals 4/3 or 1.33. Okay, I'll do 4/3. Okay, so now, how the heck do we get over here? Well, here's the thing. Let's look at this again. So these two are parallel. This is in series. Now we have the currents for 1 and 2, right? Yeah. So the current coming in here is 3, and the current here is 2. Now remember, the currents in a parallel piece must add. So in other words, this current plus this current must equal a certain number. Now that number is therefore in series with this. So in other words, I1 equals I23 because they're in series. And I23 is just, well, I2 plus I3 because they're in parallel. So we have 3 for I1 equals 2 for I2 plus I3, which is, well, 1 amp. And therefore, we could finally solve for R3. Eight equals 1 times R3. So R3 equals 8. And let's see if and again, one way to check to see if this lines up is to actually try to solve for total resistance. So 3 and 2 are in parallel. Therefore, we want to do 1 over 4 plus 1 over 8. 1 over 4 plus 1 over 8 equals that, and then we want to do the inverse of that, and then that plus R1 should equal our total. So plus 4 divided by 3. Yes. Everything else lines up, right? This times this equals this times this equals this times this equals this. Yep, everything lines up. So we got it. Now, the big boy. I'm going to move this all on its own page. Circuit 10. Okay. This is complicated. So the best way I can tell you to solve for this is to break this up basically into 2 main groups. Okay? Here's what we have on the grand scale of things. We have this branch, the 1, 2, 3, 4, 5, 6 branch, and the 7, 8, 9, 10 branch. Now these 2 big branches are parallel with each other. Okay, so in solving for we have, because of that, so we have 1 over going to equal 1 over r that plus 1 over r that. Okay, so if we get these resistances, we can then put them into a parallel thing and find what our total is. How the heck do we do that? Well, what do we have for series? Let's look at the top one first. So, what do we have in series? We have R1 and R6. Those are in series, and then these together. If we were to work these all together, they're in series. Okay. So in other words, R 1, 2, 3, 4, 5, 6 equals R1 plus R 2, 3, 4, 5 plus R6. Okay, we have that. Now we need to think about 2, 3, 4, 5. Now 2, 3, 4, 5 again is a parallel piece. We have the 2, 3 piece, and then it's sort of a double split. It doesn't really matter, right? Because we have so you don't think, oh, but it's like parallel to parallel, so I have to go like multiple layers. You don't really. You can kind of just say, well, I have 3 pieces. I have the 2, 3 piece, I have the 4 piece, and I have the 5 piece. So I have basically R1 over R 2, 3, 4, 5 equals 1 over R 2, 3 plus 1 over R 4 plus 1 over R 5. Okay, those are the pieces I have. And then R 2, 3, those are just in series. So R 2, 3 is R2 plus R3. Okay, and then now let's look at the bottom path. 7, 8, and 9 are in parallel with each other, and 10 is in series. So R 7, 8, 9, 10 is equal to R 7, 8, 9 plus R 10. And R 7, 8, 9 equals, well, these are all in parallel with each other, so it's 1 over that equals 1 over R7 plus 1 over R, it's on R, R8 plus 1 over R9. So now we have equations to solve for all of this. I'm going to actually copy this whole thing and then kind of, so you can see what these equations are, but I'm going to now copy these whole things and then let's actually work through them. Okay, so let's just put in the basic numbers to start with. Okay, so R1, we have R1. R1 is, well, okay, it's 1. And we have R6, that is 3. Okay, R4 is 2. And R5 is 4, right? Yeah. Okay, then R2, we have 3. And R3 is 5. Yeah. R10 is 7. R7 and 8 are both 5, then 9 is 10. Okay, so 5. This is 5. And this is 10. Okay, so let's see what we got. We can definitely solve this, right? Because this ends up being 2/10 plus 2/10. So this in total is going to equal 5/10. So, therefore, R789, 1 over R789 is 5/10, so this would be 10/5 equals 2. Okay, so R789 equals 2. I'll plug that in here. 2. Okay, well, it's pretty easy to say then that therefore R7910 equals 9. Okay, and you can plug that in now here. Okay, then let's see, we have 3, 5. Okay, so therefore, R23 equals 8. We have this here. 1/2 is 4/8, and 1/4 is 2/8. So this ends up being 7/8. Yes. So R 2, 3, 4, 5 is going to then be 8/7. And again, I'm going to leave it like that for a reason. So 8/7. This. So, let's see. So we have 4, 1 plus 3, plus 8/7, which is 36/7, I think? Hold on. 4 plus Yes, 36 sevenths. Okay, again, I'm leaving it as fractions for a reason. So 1 over 36 sevenths is going to therefore be 7/36. And here's the reason I have this listed as a fraction, because, hey, you can sort of... 1/9 is 4/36. Therefore, this is 11/36. So our total is 36/11 ohms, or 3.27. I'm going to leave it as the fraction, okay? Because again, I think the fractions are helpful in this case. Now we can solve for I total. We have V total is 18. So 18 equals I total times 36/11. So 5.5. Okay. So now we have the total numbers, and I saw a lot of people, or at least a fair amount of people in like Discord chat or whatever, they were talking about how they kind of got this far, and then they were like, okay, I have no idea what the hell to do now. So let's again kind of break this down. Okay, what we did with the resistance, let's break this down in terms of the current and the voltage. Okay, so let's really think about this here for a second. Let me actually just kind of jump to another page. So we have two main parallel pieces, right? We have 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10. Those are in parallel. So let's think about what are the parallel rules. Okay, what are the parallel rules? So the parallel rules are that the voltages are equal. So V total equals V 1, 2, 3, 4, 5, 6, which equals V 7, 8, 9, 10. Okay, that's the voltage rule for pieces in parallel. What's the current rule for pieces in parallel? It's a sum. So now you got to really think about how you can break this down further. Okay, so let's think about let's think about the top. Let's think about the top spot first. So 1, 2, 3, 4, 5, 6. Okay, so now what are the series pieces here? We have 1, 2, 3, 4, 5, and 6. What's the rule for voltage in series? It's summative. So V 1, 2, 3, 4, 5, 6 equals V1 plus V 2, 3, 4, 5 plus V6. And I 1, 2, 3, 4, 5, 6. Again, in series, what is it? It's equal. So it should therefore mean that I1 equals I 2, 3, 4, 5 equals I6. Again, we can keep going. So what about 2, 3, 4, 5? Well, again, 2, 3, 4, 5, we have the 2, 3 option, the 4 option, and the 5 option all in parallel. So if it's in parallel, then they're all equal. So B 2, 3, 4, 5 B 2, 3 equals B 4 B 5. If they're in, and then for current, it's that they're summative. And then we can break down the 2, 3 because it's in series. So V 2, 3, that is summative because it's in series. And then for current, they're equal. Okay, then we can again break this down for 7, 8, 9, 10. 7, 8, 9, 10, we have 7, 8, 9, and then 10. Those are in series together. So in series, we have 79. Oops. In series, it's so we have 7, 8, 9 plus V10 for current equal. And then 7, 8, 9 we can break up. They're in parallel, so the voltage needs to be equal. And the current needs to be summative. Oops, what did I do? The wrong thing. That's what I did. There. Okay, so now, just like how I broke down the resistances, all of the voltages and currents are now split up in their own things. So right, V1, V2, V3, V4, V5, V6, V7, V8, V9, V10, I1, I2, I3, I4, I5, I6, I7, I8, and I10. They're all broken up. So now we have to start to think about the numbers that we know. Okay, so what do we know? We know the total. We know the total numbers. Okay, so we know V total is 18. We know I total is 5.5. So again, let me copy and paste this before we can start figuring this out. So we know this is 18, and we know this is 5.5. How do we break this down? Well, let's just kind of think about this here for a bit. Okay, so these are equal. That means this is 18, and this is 18. Okay, so those are this here. So that was 1, 2, 3, 4, 5, 6. So this is 18. And 7, 8, 9, 10 is 18. Okay. Now, again, remember how you can use V equals IR if you really need to. So, because we can't really go any further from this, can we? Not from this here. And we can't really do the current. Okay, so what this means is that I have V 1, 2, 3, 4, 5, 6. I can solve for I 1, 2, 3, 4, 5, 6 if I also have R 1, 2, 3, 4, 5, 6. But I do. It's back up here. Where is it? Okay, R 1, 2, 3, 4, 5, 6. R 1, 2, 3, 4, 5, 6 is 36 sevenths. Okay, so V 1, 2, 3, 4, 5, 6 equals I 1, 2, 3, 4, 5, 6 times R 1, 2, 3, 4, 5, 6. So V 1, 2, 3, 4, 5, 6 is 18. And the resistance is 1, 2, 3, 4, 5, 6 is 36 sevenths. So I, that's wrong I, there we go, equals 18 divided by 36 sevenths. 3.5. Oop, I did 6.5. 3.5. So I 1, 2, 3, 4, 5, 6 is 3.5. Means this is 3.5. Now, hey, 5.5 equals 3.5 plus this. I don't need to calculate, tell me that's 2. Means this is 2. Which means this is 2. And this is 2. I10 is, okay, so that's all 2. So what have I actually specifically solved for? The only number I have actually directly solved, the only, like, number that's actually going to go in the table that I've solved for is now I10. I10 is 2. Hey, but now here, I have a connection, right? So, I can therefore say, well, V10 equals I10 times R10. V10 is 14. V10 is 14. V10, V10, V10. Where's V10? There it is. 14. Hey, wait a minute. 18 equals something plus 14. This has to be 4. Which means this is 4. Which means this is 4. This is 4. And this is 4. So 7, 8, 9 are all 4. And then I can solve for I. So v equals IR, so that means 4 equals something times 5. So this is going to be 0.8. This is also going to be 0.8. And then this is 4 equals something times 10, so 0.4. Now this was the I-789, which is, yeah, equals that was this here. So this should equal 2, does it? 0.8 plus 0.8 is 1.6 plus 0.4 is 2. Yeah, that works. Okay, so we have now solved for everything in this bottom piece here. The 7, 8, 9, and 10 is all done. 7, 8, 9, and 10. Those are all done. So now we need to start looking at the top part. Okay, so let's see what we got. We have 18, and we have this here. Okay. Oh, well, we have 3.5 here, which means I1 is 3.5. I2, 3, 4, 5 is 3.5. And I6 is 3.5. So I1 is 3.5. And I6 is 3.5. We could solve for V. V1 has to therefore be 3.5. And V6 therefore has to be 11.5? 10.5, close enough. Oh, I should really put all my variables in. Okay. Yeah, I forgot to do that for these. Okay, there are all my variables. Oh, this is not V. What am I doing? Okay. Everything else good? I think everything else is good. Okay, so we have 3.5. Okay, V is 3.5. V1 is 3.5, and V6 is 10.5. Okay, so V1 is 3.5. This is 10.5. Okay, then we can solve for V2, 3, 4, 5. We have 3.5 plus 10.5. That equals 14. This is 4. Which means this is 4. Which means this is 4. This is 4. And this is 4. So V4 and V5 are both 4. You can then solve for current. So 4 equals something times 2. It's going to be 2. And 4 equals something times 4. That's going to be 1. So I4 and I5 are 1. And this 2, 3, 4, 5, that was this here, right? So yeah, this is 3.5. So 3.5 equals something plus 1 plus 1. 1.5. Which means this is 1.5. This is 1.5. And this is 1.5. And therefore, 3 times 1.5 is 4.5 volts. And 5 times 1.5 is 7.5 volts? Make sure there it is. Yeah. That's everything. That's everything. That's 4.5 and 7.5. So let me put that in here. Wait, that doesn't line up. Crap. Where did I mess up? Where did I mess up? Where did I mess up? How did I mess up? Hold on. Whoa, whoa, whoa. this not line up? Shoot. Wait. No. This is not. How did I? No. Oh no. What did I mess up? Oh no! Oh no! Okay, hold on. Okay, let's stop back. Okay, so this. That equals 18. Okay, that equals that. Messed up somewhere. Shoot. Where did I go wrong? Numbers are also nice too. I thought I got this right. Oh crap. Where did I mess up? Where did I mess up? I'm just looking for something that's like not correct, but everything looks fine. I didn't do anything like stupid. Wait. No. No, that's right. Did I just mess up something dumb up here? Hold on. Let me make sure all this. Okay, so 1 times 3.5, 3.5. 3 times 1.5 is 4.5. 5 times 1.5 is 7.5. 2 times 2 is 4. 4 times 1 is 4. 3 times 3.5. That, whoops, I put 10. 5 times 0.8. 5 times 0.8. And 10 times 0.4. 4. And 7 times 2 equals 14. All of that lines up, so okay, here's the thing. I did build this circuit, so let me see. Maybe I'm just being stupid. Okay, let me actually see if I got this right. So, let me just make sure I got my numbers right here. So, this way and then this way. 4. Which one is that? 4. Okay, so that's 9, right? Yeah, it's 9. Okay, those are 4. That's 4. And that's 4. Okay, so that's good. And then this one should be 14 over here. 14. Okay, so that's correct. So then this one should be 3.5. That's right. 3.5. Okay. So then 2 should be. Wait. 1.5. 2 should be 1.5. Why? Oh, did I just put them in the wrong spot? Wait a minute. Hold on. 0.5. Okay, I think I. Okay, so this. Hold on. So this should be 0.5. This should be 0.5. And therefore, this should be 1 and this should be 2. Yeah, okay, but wait, but how did I. Okay, so I get what the answers are supposed to be, but now I'm wondering how did I make that mistake though? So 3.5, so this should be 0.5 plus 1 plus 2. So this should be plus, I5 should be 2. V5. Means V5 should be 8. Right? Wait. Four. Oh wait, no, this one should be, yeah. both 4. Hold on. Okay, I'm trying to just figure out where I made my mistake. That should be 4, so that's right. Oh, wait, I just put the number in wrong. Okay, I'm an idiot. Okay, good. I didn't make a legitimate mistake. I just put the number wrong. I just put this was 1, but this should be 2. Okay, that was my mistake. I did everything right. I just transcribed a number wrong. So all my numbers are okay. Leading up to this were right. If this was 2. That means this has to be 0.5, and therefore this is 0.5, and this is 0.5, and this is 0.5. Means this is going to be 1.5, and this is 2.5. Or wait, no, 1.5, no 1. Which means this. And the whole thing is that this should equal 4, which it does. Okay. Okay. All right. Okay. So let's double check, make sure everything's good. Okay. So this should be 3. So R1 should be 3.5 and 3.5. So 3.5, 3.5. R2 should be 0.5 and 1.5. 0.5, 0.5. R3 should be 2.5 and 0.5. 0.5, 0.5. Okay. R4 should be 4 volts and 2 amps. 4 volts, 2 amps. R5, 4 volts and 1 amp. Okay. R6, 10.5 volts and 3.5 amps. Okay. R7, 4 volts and 0.8 amps. 4 volts, 0.8 amps. R8 should be exactly the same. 4 volts, 0.8 amps. And, yeah, R9 should be 4 volts and 0.4 amps. .4 amps. And R10 should be 14 volts and 2 amps. And just to make absolutely sure about this, my total voltage should be 18, which, I mean, you can probably believe that. Don't really need to test that. And my total current should be 5.5. Boom. Okay. So I didn't do anything wrong in my math. My only mistake going through this was that I had written that this was 2, that I4 was 2, but yet when I originally wrote it down here, I wrote that it was 1. So that was my mistake here. I didn't even I didn't calculate anything incorrectly. I literally just wrote it wrong. I wrote that was 1, it needs to be 2, and then everything else fell into place. So there you go. That's you're able to figure this all out. This is definitely a challenge. I'm curious to see if anyone actually got this. These numbers are not that bad, actually. So that's something nice to put up. You may notice this circuit does not look exactly like this circuit. But like, for example, you notice here, so how there's like a little gap here and how it connects here. It's not like exactly the same. That's because I literally ran out of wires. And also I ran out of resistors too. So I had to make it a little bit, but you can see, hopefully you can believe that this is functionally the exact same circuit. It's just the connections are valid. Okay, there's nothing that's functionally different about it. It's just aesthetically a little bit different. So yeah, okay, I'm glad I didn't make any horrible mistake that made me redo everything. But again, this shows not only, well, I did make a mistake that made me redo a bunch of stuff earlier, but even though I didn't make a mathematical mistake, just because I just wrote down a number wrong, that threw, well, not the whole thing, but it threw a lot of decent amount of stuff in jeopardy. So you have to be very careful about this kind of stuff. And yeah, so that's that. As I wrote in the post yesterday, you are going to have some sort of test. Well, not even some sort of. It is a test. Um, in this week, and you will not have something this difficult, but you will have to do some voltage, current resistance calculations that are not. They're not just going to be, um, you know, all in series or all in parallel. There's going to be at least something that's a bit more complicated than that. It's not going to be like this. Okay, so yeah, I gave you this as an exercise to see if anyone could figure this stuff out. And again, you can see how like this is not hard mathematically, right? Well, like look at what I had to do. It's adding and multiplying and equals, and this is like if I were to just give you these math problems, like a stupid child could do this. But like the difficulty is figuring this out, working through the logic, and going through and actually making these sort of formulas and plugging in numbers and working backwards to figure this all, or working all over the place to figure it out. So that's the challenge. And I've said before that like I kind of like this in terms of like how it's difficult but built on a not difficult foundation. I kind of like that, but like I don't know. I have a feeling a lot of people don't. But that's what we got for that. So anyway, I'm kind of scared to look at how long this is. But well. um, yeah. So tomorrow I'm gonna put together a video basically reviewing all the stuff, and you'll see the formula sheet and all that good stuff. Of course, if you have any questions about anything, please let me know, either commenting on posts or through Discord or send me emails. And yeah, that's that. There we go. Ooh, I did it. Yay.